The Habitable Exoplanet Observatory, HabEx, uses a telescope and a starshade to discover Earth-like planets around sun-like stars and perform other astrophysics observations. With a 4-meter primary mirror, HabEx would have an angular resolution 2 times better than Hubble, with more than 10 times the sensitivity to ultraviolet light. HabEx would use 4 instruments. The workhorse camera and the UV spectrograph will enable new explorations of the solar system, galaxies, and the universe. The coronagraph and the starshade instrument will directly observe exoplanets. To provide an ultra-stable platform, HabEx uses thrusters for pointing control. With its thrusters, it can turn 180 degrees in 5 minutes, making it agile enough to perform rapid follow-up observations of events like a gravitational wave detection. HabEx can also downlink all of its data without disrupting its observations. Designed for efficiency, HabEx will spend 90% of its time observing, compared to about 30% for Hubble. The starshade's flower shape is optimized to block the light from a star before it enters the telescope, making it possible to directly image Earth-like exoplanets, which are 10 billion times fainter. The starshade is positioned about 76,000 kilometers away from the telescope. When using the starshade, HabEx can observe a region of sky spanning 40 to 83 degrees away from the Sun. When operating alone, the telescope can observe 40 to a full 180 degrees away from the Sun. During formation flight, the starshade's chemical thrusters fire once every 5 minutes to maintain telescope line of sight. During firing, telescope observation is suspended for 10 seconds for residual vibrations to dampen and the thruster plume to dissipate. While starshade repositions between stars, other observations take place. A truly global facility, HabEx observations will be split evenly between exoplanet and guest observer science during its 5-year primary mission. After this, HabEx will become a fully guest observer facility. The coronagraph will detect exoplanets and determine their orbits. The UV spectrograph and workhorse camera are community instruments and observe in 2 modes. They will perform guest observer programs or be used to take parallel observations. When the HabEx telescope and starshade operate together, they can observe a wide spectrum of colors at once, critical to determining if exoplanet atmospheres show the presence of life. For instance, if HabEx finds a planet orbiting another star, the reflected light from its atmosphere could be split up into a spectrum of colors, stretching from ultraviolet to the infrared. The structure of the spectrum would show you the composition of its atmosphere. HabEx is designed to identify biosignatures of an Earth-like planet based on the detected proportions of oxygen, water, methane, ozone, and carbon dioxide. But if that Earth-like planet does not have life, it might look like Earth did over 3 billion years ago. HabEx's starshade-enabled spectroscopy would distinguish between these different types of Earths to see that this one has more carbon dioxide and methane, and less oxygen and ozone. In a single observation with its starshade, HabEx could assess the atmospheres of the planets in other stellar systems to create family portraits. Throughout its mission, HabEx is expected to discover 8 Earth-like planets, and would be the first to discover and take dozens of family portraits of our nearest planetary systems, our neighbors, and see if life beyond Earth may exist.